Hey everybody, this is the 5-8 part 2 video. We are going to continue working on applications. I will say they're a bit more complicated in part 2. And we are going to start with an example from the textbook. This is number 38. There's a whole section of problems that have these specific instructions. It says an object moves in simple harmonic motion described by the given equation. Know that t is in seconds and d is in inches. We're being asked to graph one period and find the following items: the maximum displacement from rest, the frequency, time required for one cycle, and of course a phase shift. We didn't have any of those in part 1. So here is my first example, which is number 38 from the textbook. You guys are going to be doing some odds. So I'm going to start by first analyzing the equation to come up with the amplitude, the period change, if there is one, the phase shift, and the vertical shift, if there is one. So the amplitude is according to the A value. The A value is 3. It's positive, so we are not flipping in this particular problem. To find the period of a cosine function, you should do 2 pi divided by b, and the b in this case is pi. So you have 2 pi divided by pi. Oops, got a little ahead of myself. 2 pi divided by pi. And that's, the pi's are going to cancel. That's going to leave us with 2, and that ends up being 2 seconds. I'll get more into that in just a moment. The phase shift, remember to calculate the phase shift, you do c divided by b. Our c in this problem is pi over 2, and we're going to be dividing that by pi. If you think about that, that's pi over 2 multiplied by the reciprocal. The pi's are going to cancel, and you're left with 1/2. That 1/2 is positive, so that means that we're going to be going to the left. Whether you include that here or just know that in your head, that's fine. We do not have any addition or subtraction outside, so that means there is no vertical shift. I did a software update and my pens have gotten worse, so I don't know what's going on with that, but bear with me. So I'm going to go to the graph next and then we'll answer the questions. Again, we always want to be thinking ahead when we're labeling on our graph. So I know that the amplitude is going to be 3. So I'm labeling that way on the vertical axis. The period, one wavelength before the phase shift, should fit in 2 seconds. I'm going to cut that in half. That would be 1 second. Then I'm going to cut those in half. Here's a half and 1.5. But eventually I'm going to shift this 1/2 to the left. So I'm also going to label -0.5. All right, so I got my labels done. I am going to graph the first 2 items and then I'll handle the phase shift. So an amplitude of 3 with a cosine function and a period of 2 seconds. I'm going to start high. I'm going to bottom out at what would be pi, but because of the period change, it's not pi. Here is my blue graph. It is a non-phase shifted cosine function with a period of 2 seconds and an amplitude of 3. Next, I'm going to do the translations. That would be the phase shift and the vertical shift. There isn't a vertical shift though, so we are just going to take each of these 1/2 second to the left. So you should switch colors or maybe go to X's. Okay, and my red curve is my final answer. That's part of the question here. Graph 1 period. I do want to point out your textbook, what they're going to do, I'm going to write on this and then I'm going to undo it. Your textbook isn't going to show you the portion of the wave to the left here. I want you to do the graphs just how I have mine here in the notes. What the textbook is going to do is they're going to start the curve always at 0 and they're going to finish it through that period. So it's going to look something like that. I don't want you to do that. I want you to do what I'm doing in the notes here. So let me get rid of all that stuff. Okay, great. We still have additional questions to answer about this. Part A, the maximum displacement, that's going to be the same as the amplitude. So we're going 3 inches. I know that because of the units that were given. D is in inches. Question B, the frequency. All right. We didn't have much of this in part 1. Remember that the frequency is 1 over the period. It is the reciprocal of the period. So if the period of this graph was 2 seconds, that means that we're going to have 1/2. And the way that you're going to do that for your units, you're going to say inches per second. It's horizontal, vertical distance per time. Maybe we should write that down. Distance per time. Part C, the time for one cycle. This is going to be asking you your period. 2 seconds. That's the reciprocal. Part B and part C, those should be reciprocals of one another. And then for part D, they want to know the phase shift. Our textbook just says the 1/2 part. I would like you to say the direction as well. So let's say 1/2 second left. Okay, and I think you have maybe 3 or 4 questions like that. Some of my favorite applications, and you get to do some drawing. Wonderful. These are angle of elevation and depression questions. Kind of similar to our multiple triangle questions, but you're going to have to come up with the pictures on your own. Tried to get a head start here to save some time. Example 2, it says a man flies a kite and lets out 100 feet of string and does that 5 feet above the ground. So his arm must be 5 feet above the ground. All right, so I've got that. My string is 100 feet. It says the angle of elevation of the string. Anytime you're doing an angle of elevation or depression, that's in comparison to, think eye level. His eyes must pass through 52 degrees to get to the kite. And what that will do for us is allow us to make a right triangle. In all of these angle of elevation and depression questions, you're going to need right triangles. All right, we're going to be asked 2 questions here. How high off the ground is the kite? Well, I'm going to label this side of the triangle with length x. That's not going to be my final answer, but it will help me find it. I'll call that part A in this question. So if I'm interested in finding this side, I know information about this angle. That's opposite from that. And I also know the hypotenuse. That should be your clue that you should be using sine. Sine of 52 degrees is equal to opposite over hypotenuse. So therefore, to solve this, we're going to multiply 100 by the sine of 52 degrees. Make sure you have your calculator in the proper mode. And when I did that, I got 83.8 feet. You'll have to be careful on each individual question. Some of them want us to round to the tenths. Some of them want a whole number. So just look on each individual question. Whoops, I jumped the gun. My apologies. I got ahead of myself in my notes here. All right, let me back it up here. 100 times sine of 52 is not 83, it's 78.8. And then I had to add my additional 5 feet to get my 83.8. Sorry about that. Okay, now I'm ready. Part B. Part B, how far away from the man is the spot directly under the kite? Okay, that's asking for this distance. I'm going to call that length y. So I know this angle and I know the hypotenuse. I'm interested in the adjacent leg. So we should do cosine of 52 degrees equals y divided by 100. And to solve for y, you will do 100 times the cosine of 52. Again, make sure your calculator's in the right mode. And when I did that one, I got 61.6 feet. Example 3, from the top of a fire tower, look at my beautiful drawing. A forest ranger sees his partner on the ground at an angle of depression. For some reason, students have a harder time drawing angles of depression. So again, it's the guy in the ranger in the fire tower sees the guy at the bottom. So that's the angle his eyes must pass through. So in comparison to the horizontal, this angle of depression is 40 degrees. If the ranger is 45 feet up, so label that appropriately, that's the same as this part of the triangle. You can do it this way too. This would be 40 degrees as well, but because they said angle of depression, I chose to draw my triangle the other way. Okay, how far is the partner from the base of the tower? So I'm interested in this distance, which is the same as the base of that upside down triangle. I know this angle, I know things about the opposite, I want to know things about the adjacent. That should tell you to use tangent. Tangent of 40 degrees is equal to 45 over x. If you have a bridge, you may cross it. And, whoops, x equals 45 divided by tangent of 40 degrees. Type that all in your calculator and you should get 53.6 feet. Okay, I've got one more problem, and this involves our bearings. This can be challenging. You got to draw a proper picture here and make sure you're getting the bearing from the right object. So it says a ship is 9 miles east and 6 miles south of a harbor. What bearing should be taken to sail, so this is the ship going back to the harbor. So let's get ourselves a picture. Here is my harbor. You might need to know your directions. Never eat soggy waffles. From the harbor, 9 miles east, and also 6 miles south. That's where my ship is located. Get my fancy ship. All right, that's a great start. So what this is asking is what bearing should the ship take? So when I do my picture now, I'm going to think about the compass through the ship itself, and what I want to know is what bearing should this ship take. And if you look, what we've done there is we've created a right triangle using the 2 red lines and my dotted line. That'll help us know what bearing to travel on. The ship would set its compass so that they would travel back to the harbor and eventually run into it, okay? So identify the appropriate trig ratio. In comparison to this angle that I'm looking for, I know things about the opposite and the adjacent, so we should use tangent. Tangent of angle, I don't know, let's call it theta, is equal to opposite over adjacent. When we're solving for an angle, you're going to use inverse tangent of 9/6, or you could simplify that to 3/2. That will tell you theta. And when I did that in my calculator, I can't remember what I got. 56. 56 degrees. Go ahead and round to the whole number on the bearing questions. So you have to make sure, is that the angle I actually want, or do I need to find the complement? And sometimes your answer to that will be I need the complement, and sometimes not. Remember, when you're doing bearings, you want to be whatever's closest to the north-south line. So we're actually good with that 56 degrees. So now I just need to put directions with that. So remember, in bearings, you're going to name north or south first. This one is closest to the north. And from north, it is 56 degrees closest to the west. All right, we're going to stop there.